Hi students, welcome back to Ashita's Edu World. ഇന്ന് നമുക്ക് കൺട്രോൾ സിസ്റ്റം എന്ന സബ്ജക്റ്റിലെ ഡോമിനന്റ് പോൾ കോൺസെപ്റ്റ് നോക്കാം. ഓക്കെ, റെഡി? യെസ്. സബ്ജക്റ്റിലെ ഏറ്റവും ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഒരു പാർട്ടാണ് ഡോമിനന്റ് പോൾ കോൺസെപ്റ്റ്. ഡോമിനന്റ് പോൾ കോൺസെപ്റ്റ് മാത്രമല്ല, ടൈം കോൺസ്റ്റന്റ് മെത്തേഡ് യൂസ് ചെയ്ത് നമുക്ക് ട്രാൻസ്ഫർ ഫംഗ്ഷൻ പെട്ടെന്ന് ഈസി ആയിട്ട് തന്നെ കണ്ടുപിടിക്കാം. ഓക്കെ, നമുക്ക് നോക്കാം. ഓക്കെ, ഡോമിനന്റ് പോൾ കോൺസെപ്റ്റിൽ in order to find out the significant and insignificant poles, we have to consider this plot, and just in order to find out the poles, whether these are significant pole or insignificant pole. See, significant poles are dominant poles which are very closer to the origin. Okay, other than the poles are insignificant poles. Okay, all clear? In case of a transfer function that is k divided by s plus 1 into s plus 6. Okay, in order to find the value for this transfer function, just we have to apply this form. I think you all know this method, right? From this we will get a value as 1 by 5 s plus 1, b value as 1 minus 1 by 5 s plus 6, and we just take out the value 1 by 5 as common, the remaining part s plus 1 minus 1 by s plus 6. So this is the y of s value, that is transfer function. In order to find the time in order to find the value in the t domain, just write y of t and find out the inverse Laplace transform for this function. Okay, we'll get the answer as 1 by 5 e power minus t minus e power minus 6t. All clear? Yes? Yes. See, significant poles are the dominant poles which are closer to the origin. Okay, the poles here given as s plus 1, s plus 6, will get the poles as minus 6 and minus 1. Is this a significant or this is a significant? See, this is the significant pole comparatively compared to the s plus 6. So, minus 1 here, minus 6, this is the significant pole. This is the insignificant pole, right? Okay, all clear? Yes, minus 1 is a significant pole here. Okay, in order to find out the DC gain, we have to consider only the insignificant pole, and the DC gain should be find out intact. That means s equal to 0, and we'll get the answer for DC gain easily. Okay, here from this transfer function, k will be constant. So the k value we can return as k equal to 1. Just eliminate. This is the insignificant pole and this is the significant pole, because minus 1 is closer to the origin than minus 6. So this is the significant pole. Remember, should not consider the significant pole while calculating the DC gain. So just consider s plus 6, 1 by s plus 6 here should give s equal to 0. That is, should be intact. That means s equal to 0. We get the DC gain as 1 by 6, and transfer function value will be equal to, DC gain is here k. Substitute the value 1 by 6 and the remaining value, that is significant pole. Significant pole is 1 by 6 by s plus 1. Okay, other important point is, in order to find out the dominant pole, insignificant pole divided by significant pole should be greater than or equal to 5. Okay, insignificant pole divided by significant pole should be greater than or equal to 5. If the significant pole is P2, that is second pole, and significant pole is P1, that is first pole, if P2 by P1 is less than 5, then these two poles are P1 and P2 are significant poles. Okay. If P2 by P1 less than 5, then these P1 and P2 are significant poles. Minus 2 is closer to the origin. Minus 12 is not closer to the origin compared to the minus 2. So, we can write S plus 2 as a insignificant pole and this as a significant pole. Right? So, while calculating the value for DC gain, should not consider the significant pole while calculating the DC gain. So 6 by 1 S plus 12 should be intact also, that is S equal to 0. We'll get 0 plus 12, that is 12. 1 by 2, this is the answer. And the transfer function will be equal to 1 by 12 divided by S plus 2. 1 by 2 divided by S plus 2. We can conclude this dominant pole concept as insignificant pole divided by significant pole should be greater than or equal to 5, or P2 by S, that means second pole divided by first pole greater than or equal to 5. It is the first point. Second point is DC gain should be intact. That means what? S equal to 0. Put S equal to 0 while calculating the DC. And finally, the transfer function will be equal to DC gain by significant pole. Okay, all clear? These are the points to remember while doing this dominant pole concept. Okay. Next one is time constant method. From this method also we can find out the transfer function from the given question. Okay. Let us see one example, that is transfer function will be equal to 6 by S plus 2 into S plus 12. Okay. Just write down in terms of time constant. We know the time constant, the transfer function which is showing in the terms of time constant, that is 1 by S tau plus 1, right? So we can write this as in the term of time constant as here. That is, just to take the constant outside, 1 plus S by 2. Here 12 into 1 plus S by 12, right? And from this we can write it as 6 by 2 into 12, that is 24, remaining 1 plus S by 2 into 1 plus S by 12. Okay, here we'll get 1 by 4, the transfer function will be 1 by 4 divided by, see here, the tau value S equal to 1 by 2, that is 0.5, and here the value is tau 12, that will be 1 by 12, that is 0.083, right? This one is larger compared to this one, so this is the significant one, that is 1 plus S by 2. Okay, we can easily find out the transfer function using the time constant method as here. Okay, all clear? Yes. If we have to find out the transfer function as this one, that is here the one of the pole is at origin. In this case, if while doing the DC gain, while calculating the DC gain, it should be intact. That means S equal to 0, right? Here see, if S equal to 0, the denominator S equal to 0 will be the value like this. Into 0 plus 2, that is 2, divided by 0 into 3 into 4. That means the transfer function will be equal to infinity. It is not possible. So, while doing this type of question, if the check whether the pole is at origin or not. Okay. If any one of the pole is at origin, then just eliminate that pole. Okay, just eliminate that pole at origin and put the value of s equal to 0. We'll get the transfer function easy. Okay, from this we can eliminate the pole at origin. See, just apply this. That means DC gain equal to limit s tends to 0 SP. That means pole at origin 2 into s plus 2 divided by SP. S plus, just cancel these two and we'll get the answer as 2 into s plus 2 by s plus 3, s plus 4 and limit s tends to 0. Next apply s equal to 0, that is 0 plus 2 divided by 3 into 4, right? Here 4 divided by 3 into 4, 4 and 4 cancel, that is 1 by 3 is the DC gain for this question, right? Okay, clear? And 1 by 3 divided by, just to write the significant pole of here. Okay, this is the transfer function of this type of question. Okay, one question asked for gate is open loop DC gain for of a unity feedback system with closed loop transfer function is s plus 4 divided by s square plus 7s plus 13 is, which of the option is the answer? Okay, here see, one closed loop transfer function is here. We can easily find out the answer if the concept is clear. Okay, here see, most of the students got confused while doing this type of question. That is, the here closed loop transfer function is given as s plus 4, right? Is given as s plus 4 divided by s. Most of the students will find out the DC gain as, give the s equal to 0, 4 by 13. Is this correct for this question? This wrong answer also included as the option. Okay, this wrong answer is also included as the option for this question. Is this correct one? No, this is not the correct one, because they ask open loop DC gain of a unity feedback. Here closed loop transfer function is given. Okay, clear? Here closed loop transfer function is given. We have to find out the open loop DC gain. Just to find out the open loop transfer function first. Okay, here given closed loop transfer function. In order to find the open loop transfer function, we should find out the relation between closed loop transfer function and, that is, for a closed loop transfer function, we know that g of s divided by 1 plus g of s if for the unity feedback, right? Here open loop transfer function will be equal to g of s. So clear? Just substitute OLTF over here. We'll get the answer as open loop transfer function divided by, right? This is the relation between closed loop transfer function and open loop transfer function. From this easily we can find out the open loop transfer function, because our closed loop transfer function is given here. Okay, just take the reciprocal. Right? Okay, all clear? Next apply the closed loop transfer function over here. We'll get the answer as, right, open loop transfer function will be equal to s plus 4 divided by 1 s plus 4 divided by s square plus 7s plus 13 divided by 1 minus s plus 4 by s square plus 7s plus 13, right? Here we'll get s plus 4 divided by, just cancel this one and this one. We'll get the answer as s square plus 6x plus 9. Okay. Next apply s equal to 0 for DC gain. Okay. We get the answer as 4 by 9. Okay. This one is the answer. Okay. All clear? First of all, we should read the question thoroughly. And next, try to answer the question within second, right? If we know the concept thoroughly, we will get the answer within 20 seconds, right? All clear? Yes. See, this is the question asked for date, that is a plant has an OLTF, that is open loop transfer function GP of S is equal to 20 by S plus 0.1, S plus 2 into S plus 100. Okay, the approximate model by retaining only one of the pole which is closest to frequency response of the original transfer function at low frequency is dash. Type of question, that is GP of S, that is open loop transfer function will be equal to 20 by S plus 0.1 into S plus 2 into S plus 100. Okay, see, S plus 100, this is insignificant compared to this one. Only one significant pole is here. Just to find out, we know the relation by, that is P1 by P2 should be greater than or equal to 5. Okay, that is insignificant pole. That is the insignificant pole, that is 2 by 0.1. This is greater than or equal to 5. Significant pole. Okay, and find out the value for DC gain. S equal to 0, that is 20 by 2 into 100, right? We get answer as 0.1. DC gain will be equal to 0.1. Next, transfer function will be equal to, we know that transfer function is equal to DC gain divided by significant pole, right? Then will be equal to, DC gain is 0.1 and significant pole is here S plus 0.1. Here, first one is the answer. The answer for this question also find out using the time constant method. That is, this can be written as, just to take out the constant values, that is 0.1 from each and every pose. So we get the answer as S by 0.1. Okay, into 1 plus S by 2. Okay, here into 2 and into 100, 1 plus S by 100. Right? We get the answer as here 2, 10 by 1, that is 1. Okay, 10. Here we get the answer as 10. Time 2, that will be 1 by 2, that is 0.5. Time 3, that is 1 by 100, that will be equal to 0.01. Which is greater? This one is the greater one. Others are eliminated. So, we can easily find out the value for 1 plus S plus 1, right? 0.1 divided by S plus 0.1. Okay, all clear? Yes. This is another question asked. This is another question which have asked in GATE examination. Okay. Here see, consider the following system S1. Two systems are given and the transfer function G of S is equal to 1 by 2 S plus 1. We know the standard form of the transfer function will be equal to 1 by S tau plus 1, right? Here tau is the constant. Here S1, G1 of S, right? The transfer function is 2S plus 1. Here the tau 1 will be equal to 2 value. And S2, for S2, that is system 2, the transfer function will be equal to 1 by 5S plus 1. And the time constant is here 5. Okay. We know the relation between the bandwidth and the time constant, that is bandwidth will be equal to 1 by tau, right? Okay. Here the bandwidth of 1 by tau, right? Bandwidth of system 1 will be equal to 1 by 2, that is 0.5. Here bandwidth of system 2 will be equal to 1 by 5. Okay, that here see 0.5 or 0.2 is greater. 0.5 is greater, right? Bandwidth of system 1 is greater than bandwidth of system 2. This is the correct answer for this question. In terms of time constant, that is tau, we'll get the answer as, we know that the standard form of this transfer function is s tau by 1 by s tau plus 1, right? Here tau is the time constant, and time constant for the system 1 is 2 and time constant for the system 2 is 5. Which is greater? System 2 is, for the system 2 time constant is greater. Here see, here system 1 is greater, even here system 2 is greater. This one is the answer for this question. Okay, all clear? Yes. Students, I hope you understood this session. If you are having any doubt, please comment me. I will help you to clarify the doubt. Okay, like my video, share my video and subscribe my channel. Okay, bye.